f of x equals x plus 1 squared minus 9. We'll compare that to f of x equals a parenthesis x minus h squared plus k to determine what the values are. The a value is a number multiplying in front of the parenthesis, it's an invisible 1. And the h value is a number being subtracted from x, it is negative 1. And the k value is a number being added at the end, it's negative 9. Be very careful with the signs on that. Okay, so they ask us to find a sketch. We'll use the steps that we just established in note number 63. Solution. Step 1. We notice that the a value is equal to positive 1. That implies positive, which implies that we're going to have a happy face parabola. In other words, this parabola opens upward. Step 2. Step 2 is where we identify the vertex. The vertex is the ordered pair hk. We found hk. It's negative 1 for the h, negative 9 for the k. That's our vertex. Then step 3 is where we find our axis of symmetry. The axis is represented, or the axis of symmetry, is represented by the vertical line x equals h. And we know what h is. So that tells us that x equal negative 1, because h is negative 1. That is going to be our axis of symmetry. Step 4, let's find our x-intercepts. We let y equal 0 to find the x-intercept in the given equation. Now, let's go ahead and use this form of the equation, the standard form. We can always go back and use this other form at the top. But for this one, let's use the standard form. Y equals, parenthesis, x plus 1 squared minus 9. Let y equal 0 because we're looking for the x-intercept. We always let the opposite variable equal 0. Now we're going to solve for x. We'll first isolate the x parentheses by moving the 9 over to the other side. Get x plus 1 squared. And let's turn that around. X plus 1 squared equals 9. Take plus or minus the square root of both sides. We get plus or minus 3. And now we solve for x. It'll give us x equal negative 1 plus 3 together with x equal negative 1 minus 3. So that gives us x equals 2 together with x equals negative 4. That means that our x-intercepts are the ordered pair 2, 0, and negative 4, 0. Step 5. Let's find the y-intercept. That is found by setting x equal to 0. But you know, it makes more sense in finding this value to go back to the original equation and use the y equals x squared plus 2x minus 8. We can use the standard equation that we developed. It will work as well, but this one's faster. Here we let x equals 0. That gives us 0 plus 0 minus 8, which is equal to negative 8. So that means that the y-intercept is the ordered pair 0b, so it's 0, negative 8. Okay, so we're going to use all of this for our last step, which I'm going to move over here to the side of the page, step 6. This is where we do the graph, and this picture is going to be a y-axis over here on the side, and then we're going to get the x-axis up rather high. That's our x-axis, and we're going to graph the x-intercepts. Let's see, negative 1, negative 2, negative 3, negative 4. Here's negative 4. Here's negative 1. That's going to be important. And on the other side, we can go to 1, 2. This is the number 2. Our x-intercepts occur at negative 4 and again at positive 2 over here. And then the axis of symmetry is a vertical line that passes through negative 1 on the x-axis. That vertical line is represented by the equation for the axis, which was x equals negative 1. I'll just put this in a cloud because it's not really our graph. It's just a line of symmetry that cuts our graph in half. Our y-intercept is found at 0, negative 8. So let's go down here and call the lowest part negative 9, and then above that somewhere we'll have a negative 8. So the ordered pair for the y-intercept was 0, negative 8. It is actually this point. But the vertex v, which we found in step 2, is negative 1, negative 9, which is down to here. Now let's put this all together to form our parabola, passing through these points, trying to be as symmetrical as we can when we do the graph, but realizing we're not using perfect graph paper. This is really not perfect, but it's pretty close. It has all the important points in it. And we're finished.